Hey class, today I'm going to be talking about the derivatives of inverse functions. I would be doing an introduction in this video. In another video, I'll go ahead and show you the lesson that you're going to be working on. So this video will just be an introduction. I want to show you the notion of derivatives of inverse functions and how they are related to the derivatives of regular functions. So let me go ahead and begin by using an example like f of x equals x squared when x is from 0 to infinity, meaning that I have a parabola, but I'm only restricting the parabola from 0 to infinity. So that means that I'm going to have a parabola starting at 0 for x, and when x grows, y is also growing. So I actually have a half a parabola here. Call that f of x. The inverse function, if you were to take the inverse of this function here on this restricted domain, which I should also note that the range is also from 0 to infinity, just by looking at the graph. If I want to find the inverse of this function, then the first thing I would have to do is state that y is f of x, swap the terms x and y, solve for that new y that I want by taking the square root of both sides, and then determine whether square root of x is a function on this set of domain and range. And it is, so we call this the inverse function, meaning that the inverse of f is the square root of x, whose domain is x greater than or equal to 0, and range is from 0 to infinity. Now, these two numbers are no coincidence. You should know that the domain of a function will become the range of the inverse function. So this is actually this over here, and the range of the function will become the domain of the inverse function, and that you learned already in Algebra 2 and Pre-Calc. Now, my goal in this video is to show you the relationship between the derivative of the inverse and the derivative of the function. So let me draw the inverse function. This is the inverse function f inverse. It's a square root of x function. So I'm going to show you the derivative. Let me choose a point somewhere here on f. Let me choose the point 2. And if I plug in 2 into f of x, I get 4 for y. So that's a point 2, 4. Now, according to Pre-Calc and Algebra 2, you know that the relationship between f and f inverse is that both x and y are swapped. So that means that the corresponding point 24 on f would be the point 4, 2 on f inverse. Note that this is the y of f of x, and this would be the x by definition of being an inverse. They're swapped. Okay, just noting this because this is going to be important for us, so that when we come up with the formula, or when I talk about the formula for the inverse derivative, you'll see where this comes from. So let's figure out the derivative at 2 for f, and that would be, well, let's first figure out the derivative function, and that will give you the derivative of x squared will give you 2x. The derivative at 2 will give you 2 times 2, which is 4. So that means that f prime of 2 is 4. So drawing the slope of the tangent line that crosses the point 2, 4 is a positive steep slope. That slope is 4. Now I'm going to do the same thing for f inverse. Taking the derivative, noted like this, we denote the inverse derivative like this. It's f inverse prime. And taking the derivative square root of x using power rule, you get 1 over 2 square root of x. Now let's go ahead and plug in 4, not 2, because the x is 4 for the inverse function. 1 over 2 square root of 4, which will give me 1 over 2 times 2. And that gives me 1 over 4. I'm going to stop right here. I'm going to let you guys take a look at the slope for f and the slope for f inverse. What do you notice about those two? They are reciprocals of each other. So the derivative at 4, 2 for f inverse is not a steep positive slope, but a less steep positive slope. It's the reciprocal of this slope right here. So that is a relationship between the derivative of a function and the derivative of the inverse function, if you're talking about the corresponding points. So what can we say about the derivative of the inverse function? Let me denote it like this. So denote it like this: f inverse prime of x is equal to 1 over f prime. Now I'm writing f prime because we just said that the derivative of inverse and the derivative of a function are reciprocal. So 1 over f prime indicates reciprocal. Well, what value are we plugging in here? We're not just going to plug in x. We're going to plug in the y of f of x, which is f inverse of x. Now I'm going to explain this part right here. The part in the inside may have not been so obvious. Let me go ahead and do a little quick pre-cal review. So we all know that y means f of x. Okay, so when you have x comma y, that is for the function, but when you have a new inverse function, now we're talking about x, now we're talking about the y comma x, and y would be the opposite of x, but it'd be the new x for the inverse, so that would be the f inverse of x. So key takeaway for this video is this formula and the relationships between the derivative and the inverse derivative.